Okay, good day. This is Math 130 Intro to Statistics. I'm Professor McCulley, and this is lesson number 4, frequency distribution and their graphs. Let's get right to it. So today we're going to talk about frequency distributions and their graphs. We're going to construct frequency distributions. We're going to include the limits, upper and lower. We're going to include midpoints, relative frequencies, cumulative frequencies, and boundaries. We're going to construct frequency histograms. We're going to include frequency polygons, relative frequency histograms, and ogives. It is an ogive. It is a cumulative frequency distribution. All right, so when we are organizing data, there's a lot of factors that you got to think about. So we're going to talk about measures of center, variability or spread, shape. All of those things are going to be discussed later, though, because what we're starting today is just a frequency distribution to get a general idea of the kind of the shape of where the data is, how it's clustered, how it's put together. And so we're going to do that with a frequency distribution. A frequency distribution is just a table that shows classes or intervals of the data entries with a count of the number of entries in each class. The frequency, f of a class, is the number of data entries in that class. Each class has an upper limit, which is the largest number that can be in that class, and a lower limit, which is going to be the smallest number that we can put in a class. A class width is the distance between the upper and lower limit. The range is the difference between the maximum value and the minimum value in the data set. All right, so continuing. If we want to construct a frequency distribution from a data set, we're going to divide the number of classes, generally 5 to 20. Our first one, we're going to keep it simple, only going to do 4. We're going to find what the class width is, and what we're going to do is we're going to divide the range by the number of classes, and then we're always going to round up. Then we're going to find the class limits. We're going to use the minimum value in the data set as the first lower limit, and then add multiples of the class width to determine the remaining class limits. And so these multiples that we're adding, those are going to be the lower limits of the remaining classes. Then we're going to make a tally of the number of data in each of these classes. And then we're going to count the tally for each class to find the total frequency f of each class. So we're going to follow this set of steps, and we're going to do it with our first example, and we're going to use this data set for the remainder of the lesson here. And so this example is going to say, on a statistics set, 24 students received the following 24 scores. Create a frequency distribution with 4 classes. So the first thing that we want to do when we set that up is we want to find the maximum value. And so 98 is the first one that I see, and it looks to me like 98 is the largest number in that data set. And I start looking for the smallest. 64. There's another 64, but I don't see anything smaller than 64, so I'm going to go minimum there. Put a 64 in, and then we're going to find the range. And that range, let's see here, 8 minus 4 is 4, 9 minus 6 is 3, so my range is 34. So going back to this list of stuff, we're going to use 4 classes, and then we want to find the class width. So we're going to divide the range by the number of classes and round up. So our class width is going to be 34 divided by 4, and that is 8.5. So my class width is going to be 9. All right, so let's talk about my table. So I'm going to make a table here, and you can do it however you want. But if I have a title my columns, and I have 4. If I have 4 classes, I will need that size, a 5 by 3 table here. And so let's say that this is going to be my class limits. Let's say that this is going to be my tally. And let's say that this is my frequency. All right. So my class limits. the smallest number, this minimum here, 64. That is going to be my first lower limit. And to find the remaining lower limits, we are just going to add 9. So we're going to go 64 and 9 is 73. 73 and 9 is 82. 82 and 9 is 91. Now the first upper limit is going to be 1 less than the second lower limit. So 1 from 73 is 72. And then we could just do the same thing. 72 and 9 is going to be 81. 81 and 9 is going to be 90. 90 and 9 is 99. And we are good. And we have our limits here. So now we're just going to go through and we're going to make a count, a tally of all of the values that lie in each of those limits. So this first one, 98, lies in that fourth class. And then we have a 72, so we'll put a tally there. 71 is also in that, we'll put a tally. 64 is also there, put a tally. 71, a tally. 72 brings us to 5. 98 again in that fourth class. 84 will be the first one in the third class. 71 goes in the first class again. 68 goes there. 81 goes there. 72 goes there. 72 again goes there. 81 goes there. 71 there, 72 there, 81 there, 71 there, 72 there, 84 there, 72 goes there, 81 there, 84 there, and then 64 goes there. So our frequency is just a count of all the tally marks that we made. So 5, 10, 15 goes in that first one, 4 goes in that second one, 3 goes in the third one, and 2 goes in the bottom. And so this is our frequency distribution. Not too bad. All right, a couple other things that we talked about. Class midpoint is the sum of the class upper and lower limits divided by 2. That's just the regular midpoint equation. The relative frequency of a class is a ratio or percentage of the data that falls in that class. And then the cumulative frequency is the sum of a class, or the sum of a class in the cumulative frequency is the sum of the frequency of that class and all of the classes before it. The cumulative frequency of the final class should be equal to the sample size n. So this one's just each class will get bigger. All right. So an example continued. Use the previous example to find a relative frequency distribution. So a relative frequency distribution is going to have, we're going to make a table about the same size. So we'll put that in there right there. So relative frequency. We're going to have the same class limits. But this time, instead of a tally, we're going to have a ratio. And that ratio is always going to be the number of the frequency over the total. So if we go back to the first thing on statistics, on a statistics test, 24 students received the following 24 scores. So each of those ratios will have 24 as the denominator here. So 24, 24, 24, 24. Those aren't very good fours. Let's do a better job there, McCully. Good. The class limits are the same, so 64 to 72, 73 to 81, 82 to 90, and then 91 to 99. All right, the ratio, let's go back and look. It was, so we're just going to take this frequency, 15, 4, 3, 2. 15, 4, 3, and then 2. And then our relative frequency is just a percentage based on these values. So if I grab my graphing calculator and we go 24 divided by, oops, I did that upside down, sorry about that. It'll be 15 divided by 24. We'll get 0.625, and if we move the ratio 2 places, we get 62.5%. So 62.5% of the data lies in the first class, and then 4 out of 24 gives me 0.166. So we will move the decimal place 2 spots and say it is 16.7%. I should have a percent there. Don't leave your percentages off. Always label your final answers. 3 divided by 24 is 12.5%. And then let's see here. The last one, 2 divided by 24, not 14. McCully, come on, press the right buttons. There we go. 8.3 repeating percent, which will round to 8.3%. And that is our relative frequency distribution. All right, next one, it says use the previous example to find a cumulative frequency distribution. So again, we're going to have a 5 by 3 table, and we'll take our class limits here. I think we could do this on a 5 by 2 table. 5 by 2. There we go. So for this one, we're going to have our class limits. And it'll same again, so 64 to 72. Let's do a better job with a 4. And then 73 to 81, 82 to 90, 91 to 99, and then the cumulative frequency. This one's the hardest one to understand, but the easiest to do. A cumulative frequency is the sum of a class, or the sum of a class is the sum of the frequency of that class and all the classes before it. Now, here, this is the first class. So there are no classes before it, so it is just the value of that first class that we got here, so 15. So 15 goes there. This one is the sum of the value of that particular class plus the values before it. So in this class, if you remember, we had 4. And since we have 4 and 15, that's going to be 19 there. So the cumulative frequency is 4 plus 15. This class will be the value that's in it plus the values before it. So if we go back to here, it'll be 3 plus 4 plus 5, which is 22. And the last class should be equal to the sample size n. Our sample size that we started with was 24 students. So if I go 15 plus 4 is 19, plus 3 is 22, plus 2 is 24, we have the sample size n 24 for the final value in our cumulative frequency distribution. All right, moving on. A frequency histogram is a bar graph that represents the frequency distribution of a set. The horizontal scale is quantitative and measures the data entries set up by class. The vertical scale measures the frequencies. Consecutive bars must touch. You must use the class boundaries, not the class limits. All right. So let's set that up right here. Let's do an example. Use the previous example to create the frequency histogram. So again, we're going to make a scale here. And so along here, we're going to start our first one here will be 64 to 72. And then this one will be 73 to 81. And then this one here will be 82 to 90. And then this last one right here will be 91 to 99. And these are our classes. And we're just labeling our axis here. And then let's see here. The biggest one was 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We'll put that right there. And so we're just making bar graphs of that frequency distribution that we had right there. And so since the first one goes up to 15, we'll come down here. We will grab our bar and we will go all the way up to 15 like that. And I don't like how well I did that. Let's try and keep it right on the, let's hit everything. Perfect. Awesome. And then the second one only, oops, that's the, so 4. So we'll come down here. We'll put it right there. We'll go to there. We'll go up to 4. That looks good. And then the next one was 3. So we'll try and hit 3 there. And then the last one was 2. And so we'll try and make it look just perfect like that. And that's going to be, and let's label it. And so there is our frequency distributions. And so we should note, and we're going to talk about skew, but we would just as a preview to what's coming up, we should say note this data, the histogram, is skewed, S-K-E-W-E-D, left. This is certainly not normal data. All right, next one, relative frequency histogram. We'll do a relative frequency and a cumulative frequency histogram in the last 2 examples. Histogram with the same shape and horizontal scale as the frequency histogram with a vertical scale measuring the relative frequencies. So instead of a count, we're going to write down the percentages. So it's going to look fairly similar. So we'll get a table there. We'll go like this. And so along this side, we're going to do percentage. And then we'll go by, let's see, how are we going to do this? Let's go 10, 20%, 30, 40%, 50, 60%, 70, 80%. And this time, just to do it a little bit different, here we're going to go with the class midpoints. All right, so we'll write our class midpoints for this one, and let's find those class midpoints real quick here. So the class midpoints, 64 and 72, I'll use a calculator, do it real quick. 64 plus 72 divided by, oops, we want to get that answer first because graphic calculator won't do it without parentheses. Divided by 2 gives me 68. So we'll go 68 right there. And then that next class, 83 plus 80, or 73 plus 81, 73 plus 81 equals, divided by 2 is 77. So we'll go 77 right there. And then the next one was, check my notes here, sorry, 82 and 90. I can do that one in my head. 82 and 90 is going to be 172 divided by 2 is 86. So we'll go 86 right there. And then for this one, it was 91 to 99. 91 plus 99 is 190 divided by 2 is 95. So we'll put 95 there. And then we'll do those relative frequencies. So the first one, let's get our shape tool. We'll get our bar graph here. And so that first one was 62.5. And so we'll come up to just halfway between, actually we should be, since we're going by tens, this should be pretty close to 60. So we'll guesstimate right there. And then the next one was 16.7. So 16.7, the first tick mark is 10, so just a little bit more than halfway. We're eyeballing it here. And then the next one was 12.5, so just a little bit above that first tick mark. And then that last percentage was, and just, these are the percentages that I'm using, the 62.5, the 16.7, the 12.5, and the last one, 8.3. So on that one, we're going to be just a little bit below that first tick mark to demonstrate that 8% right there. All right, there is our relative histogram. And finally, we're going to do our cumulative histogram. And so the cumulative histogram is going to be similar to the last one. And again, it's going to be cumulative, or it's going to be, start over. The cumulative histogram will use this cumulative frequency distribution. And so our bar graph, the tops of our bar graphs will be these values right here. And so if I throw this up, and again, this is going to be the frequency. And so this first one will be everything that is less than 73. This second one, and where am I getting the 73? I'm getting this top thing. So the start over. Don't use thing there, McCully. I'm using the value for the lower limit of the class above it. All right. And so this next one would be everything that is less than 82, because that is the top of the third class. And then everything that is below 91, the top of the next class. Well, the next class doesn't have a top, but we can still follow that same pattern and say that one more than 99 makes that this class would be everything that is less than 100. And so we have to go up to 24 this time. So let's go by fours. So 4, 8, let's go 4, 8, 12, 16, 20, and then 24 at the top. That's how we'll get there. And so this first one, if I go and review my cumulative frequency distribution, I have 15, 19, 22, and 24. So if I come down here, the first one, 15 should be just below 16. The next one was 19, so just a little bit below 20. And then the next one was 22, so about halfway between 20 and 24. And the last one was 24, so we will try and match it up as perfect as possible. And so this is my cumulative frequency histogram. And you should note that this will always be low to high. All right, so it will always have an upward slant to it. Well, that's all I got for this lesson today, folks. So today's Marvel fun fact of the day: in Thor Ragnarok, Thor's line, "He's a friend from work," was suggested by a young boy involved with the Make-A-Wish program while he was making a set visit, and was incorporated into the final film. So that's kind of cool. I like the fact that Marvel helps those who are a lot less fortunate than them. Well, that's all I got today, folks. See ya. Bye.